Okay, you should be on the reading to learn side of 11.6, so this would be part 2. Some of this is going to be a little complicated. I'll warn you now. I'm going to add some things at the top that I want you to write so that will hopefully help you understand this part here with the ratios of similar solids. There will be a question like this on the test about the similar solids and the scale factor, and using one of these examples might be helpful for you. All right, so I'm going to draw, let's do a square and another square, or a rectangle and another, well, no, that's not going to work. Let's try this. Okay, I'm going to draw a square and a similar one. Ignore that one over there. We're going to say this one's 2 by 2 and this one is 4 by 4. And I'm going to find the area of this. The area of this one is 2 times 2, or 4. And the area of this one is 4 times 4, or 16. So I'm going to look at what we did to these similar figures. When we went from 2 to 4 on the side lengths, the scale factor, or what you multiplied by to go from one to the other, is 2, because 2 times 2 gives you 4, 2 times 2 gives you 4. The scale factor is what you multiply all the dimensions by to get the new figure. Okay? So that means even though the side lengths were doubled, when you doubled the side lengths, what happened to the area? The area went from 4 to 16. That's not 2 times bigger. The area, if you double the side lengths, the area will be the scale factor squared bigger, or 4 times bigger. Okay? Side lengths got bigger one time, but because you multiply 2 dimensions to get area, this side is 2 times bigger to get this, right? And this side becomes 2 times bigger. Well, 2 times bigger and 2 times bigger is 4 times bigger. So the area would be 4 times bigger, the scale factor squared. All right? Let's say that this was a 3-dimensional cube. I'm not going to draw because it would probably be a disaster on here. Okay, let's pretend this was a cube, and the cube is 2 times 2 times 2, which would be 8. All right, what if I double all the sides? That means I have 4 times 4 times 4. Well, that is 64. Okay, so now when I double the sides on a 3-dimensional object, I double this one, I double this one, and I double this one. Double times double times double. When you do the volume, it's to the third bigger, which means 8 times bigger. Okay, you saw that from 8 to 64, that is 8 times bigger. So volume is 8 times bigger. So depending on the dimensions, if your scale factor, if you're doubling the side, that's one side length, 2 times bigger. When you double the 2 dimensions that you have to multiply, that makes it 4 times bigger, or 2 squared bigger. And when you double all the sides and it's 3 dimensions you're multiplying, that double is to the third power, and so that is 8 times bigger. So let's go to what this is saying now after I just showed you that. If 2 solids are similar with a scale factor of a ratio of A over B, so a scale factor, to find a scale factor, you can put A over B, or A over B this way, and say 4 over 2 is 2. That's how I got my scale factor. So a scale factor is just taking the image and dividing it by the original, and that gives you your scale factor. That tells you what you multiplied by. So that's what this fraction is. So if my scale factor here was 4 over 2, right, it would be 4 over 2, which is 2. Okay? Let's do that. Let's do 2 over 1. Okay, we'll reduce it. Then it says the surface areas have a ratio of A squared over B squared. So the ratio of the surface area, which would just be one side like I did here with the area here, they're telling you that would be 2 over 1 squared, which is 4 over 1. 2 squared is 4, and 1 squared is 1. Then it's telling you the volumes have a ratio of a to the third over b to the third. Okay, so I take that same ratio, that 2 to 1, and if it's 3 dimensionals, then that means you would cube the scale factor. So that would be 2 to the third is 8 over 1, which I already told you would be 8 times bigger. So that's using that, what they're saying there, using numbers. That's probably helpful to use numbers, because when you use the letters it gets kind of confusing. All right, so what we're going to do with this is we're going to try and find the volume or the surface area of one of them that's missing, knowing what the ratio would be of the side lengths and what one of the volumes would be. Okay, so there's a couple like this on your homework. There are none like these two on your test. There's one that kind of uses this up here, where you could draw a picture and prove why it's true using the pictures. So an example similar to what I did. These two here will be on the homework, but they will not be on the test. All right, so it says these solids are similar. Find the surface area or the volume of the larger one. Round your answer to the nearest tenth. So we set up proportions. If we're trying to find the volume, we have the volume of the smaller one, and the larger one I don't know the volume for. So that's my x. So my ratio that I'm going to set up is 250 for the volume on the top one, and x or v, whatever you want to use, for the volume on the bottom one. Okay? My ratio would be, since I started with 250 on top, my ratio of the corresponding sides would be 3 to 4. So I'm going to set it up with 3 to 4. Okay, but the ratio for the volume, you have to come up here, has a third power. So you're going to put the third power here, because the volume is always going to be whatever the scale factor is to the third power. So I am going to rewrite this using my powers. When you have the power on the outside, the power goes to the top and the power goes to the bottom. So, oops, I'm sorry. That would be 27. 3 to the third would be 27. And then 64. All right, so all I did was 3 to the third is 27, 4 to the third is 64. I now have a proportion. I'm going to multiply. I get 27V is equal to, cross multiply this way, that actually comes out to 16,000. I will divide both sides by 27 if you want to show that part. And I think it says to round to the nearest tenth, so that's 592.6 millimeters cubed, because it is a volume. Okay? All right, for the surface area one over here, I'm going to find the surface area of the one down here. I don't know the surface area. So I'm going to set up, because they're proportional, I'm going to set up a proportion of the surface areas to the sides. So the surface area would be 130, I'm hitting a button that I shouldn't be hitting, 130 over the surface area. And because I started here, I'm going to put 6 over 10, but surface area is to the second power. Okay, so I want you to try these. You know, you might think they're tough, it might be a little confusing. Go back, watch it a second time, model what I'm doing on your homework. 6 to the second power is 36, and 10 to the second power is 100. I do not want you leaving these blank. Based on what I'm doing here, you should be able to model this and go ahead and set it up. When I cross multiply, I have 36s. And when I cross multiply, take 130 and add 2 zeros. What I don't want you to do is give up and say you tried with a blank paper. Okay? No harm in trying. You might do it wrong, but we'll fix it. I will divide here, and I will get 361.1 feet. And because this is surface area, it is squared. Okay? I'm going to move this up. I have the ratio of the corresponding linear measurements of two similar cans of cat food is 4 to 3. So if the ratio is 4 to 3, that means 4 over 3 this direction, okay? The larger can has a surface area of 100 square inches. So we're going to do this kind of like this. It just doesn't have a picture. Find the surface area of the smaller can. So it's the 2 cans, corresponding linear measure is 4:3. So if I know the surface area of one of them is 100, we'll do A here, 100 to an unknown amount, and I know that the ratios for these are 4:3. If it's surface area, remember surface area or area in general is whatever the scale factor is squared bigger. So I need to use that. You must simplify before you cross multiply. So 4 squared is 16, 3 squared is 9. Then you can go ahead and cross multiply, and I get 900. Divide both sides by 16, and you get 56.25. I think it said tenths, so that should have been 56.3. But sometimes I round to 2. All right, then for B. The larger can has a volume of 150 cubic inches. So the volume is 150 cubic inches. Find the smaller can. Okay, again, the ratio stayed the same, but because it's volume this time, it's to the 3rd power. So now I got 150 over V. 4 to the 3rd is 64, right? And 3 to the 3rd is 27. Cross multiply, get 64 V. Cross multiply, and you will get 4050. You'll divide both sides by 64, and it comes out to 63.3 inches cubed. So if you have to go back and watch it again, you can go ahead and do that. There will be some problems like these on your homework, right? 1, 2, and 3 on your homework. I want you to try them. You're going to set up a proportion. Remember, if it's surface area, whatever the scale factor is, you're going to square it. Volume, you're going to cube it. So if you follow this pattern, you should be able to attempt this. There shouldn't be any blank papers. And this is what you would do for showing work on these.